Hello, welcome back to the stream. I'm Jun Chan, and we're back doing some Purescript. And we're in a detour. We're in deep inside a rabbit hole, and you can see that because of how indented. Okay, how indented? Yes, this particular section of our to-do list looks like. So let's do our usual. Housekeeping for our log. We're low on battery. Okay, we can fix that. And yeah, that's done. And so what is the rabbit hole? Well, rabbit hole, I explained it in last time, so I won't spend too much time, and I'll try and jump into the meat of things. I was looking I was rereading the book by Sandy Maguire, Thinking with Types, which has a section on existentials. And he described this type any, which is for any A, as an example of such an existential. Apparently we can't do that in Purescript. I thought we could. Is it how this is done? No. Yeah, it is. I think that means the same thing. Let's shall we check in the REPL maybe? Let's go maybe here. Spago REPL. And let's see whether we can just define data any. Makes me think that I think my pull request got accepted for Purescript non-empty. Approved. You might want to add some docs to the instance, clarifying the usage of pure might be incorrect in some circumstances, but it should work for most usages. Okay. That sounds good. Yeah, we can do this, but maybe that's a further rabbit hole. Okay. So apparently the idea, what is the type of like any 5 in a list? Let me go back and look at what some of the examples that he was giving were. Okay. Yeah, he was doing exactly something like that, but apparently we can't do that. How about any true? No, we can't. So this might, the fact that we can't put the for outside, maybe that's that makes it mean something different. But we couldn't, right? It's not a parents thing. It is not. Okay. I think we can minimize this. Purescript existentials, existential types. Existential types as a library. Maybe that could be useful. Exist stream FA. Exist AFA. Interesting. So yeah, maybe it would be interesting for us when we try to map the F to something. I think we came up to with this whole thing being the f. But maybe that would work. I don't know. Maybe we need to play with exists. But that's not really what we want. Roll out your own existential type without using unsafe coerce. So okay, existential quantification. Type exists f for r. So that's the type of like this double, this Yoneda-ish thingy. We use a rank to type instead. Okay, so maybe it's just that we can't do it as a data type. No, or is it? Hold on, what's going on there? Oh, a cycle. Right. So yeah, because there's no constructor, but that works. Okay. So let's play with this a bit. See what's up. Can we do now any 5? No, because there's no type constructor for it. So how do we, oh well, we just say that 5 is of type any. But we can't, because that would be defining it from outside. I think so. And I think we can what does it say? Any is capable of storing a value of any type, and in doing so forgets what type it has. Type constructor doesn't have any variable, and so it can't remember anything, right? The type any doesn't have any type constructor. It doesn't have an a here, so it's forgot its information, and it's not storing it anywhere. So in order to introduce a variable for any to be polymorphic over, you can use the same for all a as when working with Rankin types. This a type exists only within the context of the any data constructor. Are we really saying the same thing here? Or, because this is what Sandy writes, and we can't write that. Can we write a new type like that? No, we can't. Or new type exists. So that's, I think, is what we saw in exactly that that library. Okay. Can you call example of existential type is type class show? So it is using a showable. And so are you saying that this is okay? So let's try this new type any. And so you're saying it's actually for a to r to r. Okay. So I mean, let's imagine we have a thing like that, and let's just comment out everything, and let's get this maybe in a REPL 2. Yes, here. And yeah, we'll import that any, and we try to play with it. So we can do an MK showable. Okay, so MK any a equals anything that, and then returns an a, and then MK any is of type for a to any. Yeah, that sounds like it would work. I think maybe it's already there. Do we have MK? Oh, well, maybe we need to reload. And we have MK any now? No. Okay, so let's import data.set.monad.any. Not like that, maybe like that. And then, oh well, we need MK any as well, please. And then we make an any, let's say, what's the type of MK any 5? Array any, and we don't know what's in there. Okay, so now we're cooking with gas. And we can make a heterogeneous list like that, which is one of the examples that Sandy gives. Okay, so that makes more sense. So we just need, so that's the basics, I suppose. That's the simplest possible such type, in fact, I believe. So what else is he doing with that? Yeah, he's putting a string as well. Oh, good. So that's great. In fact, interesting. What's other than it? No, it doesn't exist here. It? No. Yeah. Okay. Yeah, I suppose that's fine. It's just that in the Haskell REPL, apparently, yeah, it's just that this this gets repeated. Okay. So and then he goes on describing lm_any, which allows us to consume an any by and so I'm now writing what Sandy has, but probably we're going to need to write it differently here. Although this looks quite a lot like this type, right? And apparently we just say that we were being passed an f, we could transform an any a, and I don't think we can write this here, but maybe we can. Then we could apply f to a. So it's let's see, does this, so we need to fall r outside. But yes, it would potentially work. So let's say that now we have some a that's equal to that. And then we want to try to lm_any, then what will we pass so that we get something out of it here? And this f, let's see. Well, so right, we need to map lm_any. That's one thing. So maybe we do applicative style here, or maybe we just fmap lm of our f, whatever that's going to be. What is it going to be? Well, we want something, well, let's use show. Okay, lm_any, yeah, okay, sure. We need to re-import our stuff. We need to get our a. Well, we already have an a apparently, so that's fine. And then we can try our lm_any. but of course it's not showable. Okay, so in this case, there's probably, we don't know. I think that reminds me of something we wrote last time, right? Which is that you will usually want that type to belong to a specific class, or you want to pass some function along that can work on that type. Otherwise, you have some value belonging to a random unknown type, and you won't be able to do anything to it. That sounds like that's exactly the case we're in. So let's see whether we, how that works. If we say like that this is B, can we now all of a sudden use show on it? We can't, because I suppose it's supposed to be working on any, oh no, B, sorry. Yeah, still we can't, because I suppose we, well, we don't know. Our B doesn't contain any information. The type of B is any. So we don't have any information about the type. And so the type checker can't, even though if we didn't have type checks, I suppose we could do this and then we'd be in a dynamic language. But since the type checker can't show here, and let's just make sure that we're not doing something stupid, by the way. By doing something like that, for instance, and make sure that works. Or like this, right? Yeah. So then, if that's the case, that because we don't carry any constraint and we can't do anything with it, then I suppose that's when we start moving our constraints inside our type. But before we do that, which is this case, let's see whether actually we can do the other case, which is mentioned here, which is pass some functions along that can work on that type. So what does that look like? Oh, hello. There's an ant here. That's not good. Okay. Okay, so let's try something slightly different, where we call it any prime, where we also have a constructor, but this time, instead of just having this A, we pass something that what? We pass some function that can do something on an A, like for instance, a function that takes an A to string. And then we do these folks. Can we do them the same way? Make any prime. We want this to be primes. It's kind of a poor man's show, really, what we're doing here, right? It's like the explicit passing of the show instance, which is A to string, as an explicit function there. Okay. Oh, I must be missing appearance. I am, but I suppose I could do this. I think, yeah. But then here we want to pass a function, and well, we can't pass show here. But we can pass the A to string function. I think that's what we want to do. And so now we make it with an F, and we just put the F in it. Except that's not exactly that. Why? So MK, and he takes an A and then puts it into a anonymous function. That's something that waits for an A to R, passes it the A, and then gets an R. And that's the content of our any. So I need to say that again. This payload is something that waits for something like that and returns an R. Yes. Yes. So we're saying it's a function that returns an R. And how do we get the R? Well, we pass it. We take that function and we apply it to A, and then we get our R. So here where we say we still have a function, and then what we get passed is now this guy. And so we just pass it an A and an F in order to get an R. But not like so, like so. But that's okay. Yeah, we can't use anonymous functions like so. That's fine. We can say this X, you just apply it. Yes. And the LM, for some reason, then it looks the same, but that doesn't seem right. Apparently that type checks, which is pretty interesting, actually. I wonder what that means. Maybe we'll play with this guy. I don't know why, but it seems interesting. But more realistically, what we pass is an A2 string here. Is it to R? A string to R and any prime, and we get an R. That sounds correct to me. And does this step check? Doesn't. Why? Because now we are F. Right, in our any prime, we have a thing that's this A, which is this function, and we what do we do here? I just want to make sure that I get this one right. So I'm going to just what is this? Extra expanded? Yeah, of course. Why am I doubting myself like that? Okay. So our F is now this crazy thing. And we've encapsulated this thing into any prime. I want to point out that we weren't able to use lim any at all, but yeah, I suppose that's because it's a value belonging to random unknown type, so we won't be able to do anything to it, which sounds reasonable except for ID, right? Can't we pass ID? Oh, I mean identity. Hey, if we do that, then we escape the scope. Can we force the type of this? Say, well, let's pass B and say, get me an array of strings. can't start with a... It's a bit strange. Okay. No, okay, so maybe we can't do anything with it. I'm a bit stumped here. I don't know. Here we can't pass the actual functions, so that won't work. So let's focus again on this. Here we get past our function of a to r, which is exactly the one we need to get a final r. Exactly like that. But that's the one we need to get a final r. And so the f that we have, we're saying pass it, because it's one of those, and then it will work. I think parents something, no? Full R, AR to any. This seems well delimited. The R here is the same as the R here. There are two A's this time, but hopefully that's not a problem. But you're not able to make that type match. And however, you're able to make that type match for some very strange reason, to be honest. Because we're not talking about any prime, not any, and for some reason this simply works, and I can't wrap my head around that. Let's just make sure we're not having hallucinations here. I want to see this thing type check in another environment, and I'm going to go grab something to drink. And I'm back. Okay. So Spike build succeeds, and so if we repo in that, let's import the thing with primes. 1 second here apparently, and then let's make an any prime which would be with like a 5, and then something that turns 5 into a string. Let's just say it ignores the value and then returns 42, like a very sane function. We can do that, right? And so let's say that this is our A. What's the type of A? Any prime. And now if we try to lm any second with, I don't know, a function of a to r, Okay. Oh. Yeah, the question is, if we want to go to string here, then we don't need to go to R, and we know what we go to, and that's one way to eliminate. Oh, maybe. We need to then see what the show version is going to look like. But so in this case, I suppose we're still stuck with this. We have no way to know what A we get past. So there's no proper function we can give here with no constraints. So, and apparently that works, which is strange. But maybe it's just that this R is this, maybe A to string, and we don't care, something like that. Okay, why not? Let's try and do the version with the show instance. So with the show instance, we're trying to say something like new type. Let's say any show equals any show for R, for A, show A to R to R. And then we can make an any show A by just doing basically exactly the same thing. I don't think we need to say anything else here. And that's an A, and that's an A, and that's an A. And indeed, all of that is correct. Thank you, type checker. And so now we eliminate any show with the function, I think, that will have the show instance, which therefore can do something to A, into transform into an R, and then this any show and giving us an R. And then it's probably just going to be exactly the same thing, which is that it sets this F, this any show with an A inside, and then it's just going to apply the F to A. And apparently that's not true. Well, that's cool because that's similar. Is it? I think it's similar to the error that we're getting here. So let's go and find the solution right here. mkshowable does this, and then we can create an instance for it. That's how the elimination is done. That makes sense. So, but I think it should still work in this old school way, right? But let's try and write it properly. So we're saying that now we can make an instance, a show instance for any show by saying show of any show A is a show. Interestingly enough. So any show A, and A is this guy. So when we pass it this guy, which is which show has this type, then we're good. But why can't we write this though? Here the idea is like, yeah, we've passed that function there, so why couldn't we apply it? Is it that we need to actually rely on some kind of explicit application? No, it's just that there's no type class instance that's found for F, but hold on, there is, right? It's being passed right here. Which is, I think, why Joseph last time gave us that for R here as well for passing our show instance, which will require for all A here as well. And then set A to R sounds right. Okay, well, but that's good. I think that we're here. That I think is a minimal reproduction of our problem. Why can't we do this? Blah blah blah. We make those showables. And then we show them. That's all well and good. Why can't we pass this? So that's the instant head contains unknown type variables. Consider adding a type annotation. Okay. Okay, I suppose that would be fair. But it's really simple though. It really is this. Whoopsie. Okay, I don't know what I'm doing. Okay. Still, no type class instance found. Do you need to know that this guy has this type? No. Do you need to know that A has this type? A has this whole thing as a type. Does that help you out? It does not. Do we still have the Purescript online? Oh, how is this called? Try Purescript. Try Purescript. I think Thomas Hanneman was working on putting that back online. So we are doing this guy, aren't we? And theory, yeah, that's where we have. And so we need to put it in a gist or something that the Derio think that's the dealio. And I think I just reset the thing as well. Okay. Just we put our code, and it's existential types with constraints. Example purse, and it doesn't need to be secret, and create it, and then share code using gist equal gist idea, gist id, gist equal gist id. Oh, whoopsie. Main.purse, okay. Maybe it must have changed. Main.purse, what did I do? Is it the cache? Must be the cache. Ah, there we go. Okay, I see. Yes, we need to make modules and things. Module main where import prelude. The cache is not helping us out here. There we go. And that's what we want. Okay. So I think we can get rid of the session and go back to our thread and say, continuing on this today, and stuck with oh, I don't need that crazy type there. The type annotation. So let's edit it again, and let's try and just do FA, because that should be able to work, but yeah, doesn't. And I'm stuck with maybe it's the elim show that needs the constraint now. Yeah, it's tricky though. So could be like this. No, because we haven't defined it yet either. Yeah, so no, I don't know. Okay. And I'm stuck with how to, I mean, yeah, instance is fine, so maybe I'll add the instance. How to do an explicit elimination, I suppose I could say. How to do an explicit elimination. And I can pass my gist. I think I'm missing a type annotation, but I'm drawing a blank. Let's play more with this, but what we want to say that F has a show constraint. Is that the right way to say this? Yeah, I suppose so. Like this value carries a show instance with it, but apparently. So let's maybe try and Google this data class instance of Purescript. You know what? I have trouble reading myself. No type class instance was found. High rank types. Poly kinds. Do I need to provide some kind annotation? I don't think so. Type safe routing. No type class instance was found. Blah. So it is the same error message, but that's type level. Machinery. I haven't said anything about the content of the params record. Doesn't seem related. No type class was found. That's a big guy. Doesn't seem like that would help. Do we have Purescript no instance found? Do we have one of these error messages now? The pages causes and fixes can find instance in the show example above. Yeah, I mean, so foo doesn't have a type class instance. That's fine. And then here we don't have a functor instance for fooey. Trying to derive an instance functor bar. It tells us how we need to derive also an instance for free. Yeah, so that's we just need to derive an instance for free before, right? That's what it would be, I think. Oh, flip it around AF. Duh. AF. Oh my. Of course, and I had a show underneath all the time. Okay. So maybe we can go back to our elim prime there because it's just AF as well, isn't it? And then the question is how does that even work? And did this ever work? And did I lift this? I think I lifted this, but then incorrectly, didn't I? No, I didn't lift it incorrectly. That looks like a typo in Sandy's book. Okay, I'm going to make a note out of that. Lean pub, thinking with types. I'll need to go to my account. Should I do this now? Yeah. Okay. Is it written? Okay, I think I need to do this later. But okay, that makes sense. And so does this mean this is also AF? And that is just type checks. That is a tricky little thing. Wow. Then in this case, AF and FA actually both type checks. That's like a type checker palindrome or something. I think it's just an I. Little brain explosion, maybe. I mean, is that, yeah, no, that must be rare, right? When is that the case? That FA type checks, it's not just that it type checks, it's also equal to the same type. So it's like a reflexive. Okay. Okay. So that's weirdness, and that's fine. But then maybe we can try and use some of that kit. Let's try the show instance, and I suppose we'll reload the module. We'll import also any show with the constructors. I think we don't need to do constructor dance here. And how about we import everything? What am I doing? Why am I doing this to myself? Okay. Well, maybe you reset then. That may be clear. Okay. Clear and reload. And then import this. And then do like our A equal this guy, but with, yeah, with any, that's fine. But no, then we can't do anything with that still, right? I don't think I invented a way to do so, but maybe with our mk any prime now we can. So let's see if we do. With a prime, we make any prime, but we're going to need to pass some function with it, right? That's the idea. Here we implicitly pass a function with it with the showaway constraint. Here we pass it explicitly, or here rather, yeah. So here, okay, let's say that we pass 42 here, and we can ignore the input. It's really const, right? Yeah. 42 false, and yeah, const goodbye. Okay. Okay, and so now if I try to elim any prime with, so with what? With a function that given is it a function? It does, yeah, it's supposed to be that whole crazy thing that so that takes this function, it takes the A string. Okay, well, fine, let's write it. So we want to elim any prime, so we'll put a function here, and for now we'll just run it with just a simple thing, because otherwise we need to deal with the array and the functor, and let's not do that for now. So here we're supposed to have an f that is a function that takes an a, an f, which is a show function, and then just basically applies the f to a. Isn't it what this does? And that gets us a string. Almost. You don't know what dollar is, really. I didn't import prelude, I see. That's why I didn't have const either. That does work. Okay, so we have some basic understanding of how this works, and the fly just went inside the microphone. What the? Yeah, it did. Okay. Some ants at the beginning of the stream on my monitor, and now a fly in the not in the ointment, in the microphone. Okay. So that's pretty cool. And so I suppose that now we can do something like using our f map to actually apply that to our a prime. And indeed we can. That's pretty cool. So I think we have the template to sort out our set monad now, if we have the wherewithal. So let's get back down to it, and let's wear with as much as we can. The fly has gone somewhere else. Okay, so first of all, yeah, we kind of know that now it's pretty clear we need to use this definition for prim in order to pass the ord instance, indeed. And remember that actually this is one of the errors that we had, which we couldn't access the ord instance. So now we should be able to have it, but how? So our prim has this payload. Very much like our any show has this payload. And how do we make a prim? Well, we'll need something to make a prim. We need a smart constructor that will be something like prim blah, right? Like prim not so blah. Hold on. What? We just take the A and make it any show with it. Yes, yeah, maybe you will. I just need to carry the ord instance and then we're set. Interesting. And in fact, we're set with the set, I think. So we carry the ord, we put the set, and we get a set A from it. And how it works is that we take our set and we wrap it inside this a function that takes a well, we wrap it inside the prim constructor, and I suppose with this guy then. Maybe. Let's say that that's the case. Can we put this here to see if it type checked before? No, we're not fooling the type checker, I don't think. Or it's a different pass. But let's imagine that that's right. So now what? Now here we're trying to eliminate, aren't we? But yeah, the question is run, does run, I think run in the set monad that we were looking at, I don't believe that run has an instance on it, does it? Run, oh it does. Ord has the ord instance on it. Okay. So then why don't we have our S here? So we have our S, and how do we eliminate it? We just say S show. We pass something here to, well, here we don't want to produce a string, right? So we don't pass show in order to get the R as a string. The R that we want is the S set. Which is the regular set. So maybe we just pass it ID, our identity, and we have some stuff going on in there. Maybe it's not. Let's just double check that our chat is up and running. Yeah, it is. Okay. Okay. Yeah, hold on. This worked. It makes sense. It makes sense. Okay. So now what? Now bind is a little bit tricky. Because bind, we won't be able to pattern match. So all of that stuff is going to be done on in a case or whatever, something elsewhere, I think. So let's keep that somewhere. And then let's imagine that we have run bind. And this time we can't say really what's in it. It's just an existential. And then can we guard? I don't know. Can we will see what we can do to match there. What can we do with our E? So similarly, we can pass it once we've unpacked it. We can apply it to some function that knows what to do given a function like so. Maybe I should limit the notification just a tiny bit. So I'm going to, how am I going to do that? User settings. Is there a, what is a streaming mode? Isn't there a streaming mode? Streamer mode. Yeah, that is, I mean, it disables all notifications, unfortunately, but or it disables sound. Maybe I don't disable sounds. I think that might be that might not be what I want. I might need to just mute the whole thing. I don't know. Not clear. Okay. So we have an E. That's this. And to eliminate and get something inside, we'll want the something inside to be, again, to be S set, like R will be S set, right? It's the same thinking that we did for prem here. So if we write this and then we say this will be really S set A, and this would therefore give the S set A that we want, then we pass it a function like so. And we think hard about what that function would be in the way, exactly the same way here that this turned out to be this pretty simple thing. Well, let's write param here, where we replace this by S set A and S set A. And we didn't have to really think hard to know what this function is. So, however, here, this is, well, this is bind, really, right? But bind leading to a set, an actual set, rather than our set monad. Right. So now this function is going to be the one that, so it's, let's call it f, very imaginative, where, well, this function f, it's going to be able to pattern match on the set B here. And I think, right, yes, the first bit, and that's prim s. And the second one is, well, okay, fine, go. The second one is going to be f. And then in that case, we do what? In order to, well, in that case, we do that crazy thing. And is there anything else we need to do? Apparently, yes, because we have prim s, and so therefore we just do the same thing, passing it identity. And then if it tells us we don't have we haven't covered all the input, we're really on our way, I believe. Yay. Okay, so that's this guy, yes, and so therefore this is go return a f, and it might be the case that we would better serve copying the Haskell code here, because it was closer to this notation. Yeah. It's not going to save us much time, so it's not worth it. Does that type check? Yes, it does. Excellent. So go and okay, fine. Let's automate that a tiny bit. Let's say that run bind is go. And then plus, actually I think I might have needed that here. Okay, what am I doing? Bind here. All right, the nested thing. No, the nested thing is legit. Ooh, that's going to be fun. We are going to need to make this opaque and then do the same trick. Wee. That's going to be tough. And then we have a bunch of closing parents. And what's blowing up now? Oh no, damn. I put go in there. I see. Well, my bad. And yeah, plus I'm not sure how that's going to work. Is this, how is this parenthesized? It's this plus and then the f. So So this should be fine. Maybe. Plus an F and plus an F. Okay, what are you telling me now? Given this length, differ. Blah blah. Yes, right here it differs. It still differs. Okay. Yeah, here it totally differs here. Okay, it doesn't differ anymore. So where we have S, yes, so that's its identity. And then something interesting. I added these unsafe cores, by the way. We're not sure. Oh, because we're trying to make a prim here. So we just do prim and giving the F. And well, yeah, we'll need a bind to make a bind. And that's going to be pretty complicated. So how we do that? It's going to look a lot like our make any prime. And here's going to be set A again. And then it's going to take, I think, this basically, right? But maybe with the for B, possibly. And I think that's probably right. Something like that sounds reasonable. And so then it takes two sets, or a set, a function, and then what does it do with those things? Well, it creates a bind. And probably it just, well, maybe it just applies the F to the S and then it's happy. Maybe. If that's the case, then this bind then the bind. Right, bind. So it's this F is not applied to prim, it's bind. So yes, so it will be bind of prim blah 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 and F. Except missing appearance. And oh, so that's not right, but maybe it's just this or not. Okay, let's make sure we are doing the right thing here. Let's get this again. Visible for us right here. And let's properly compare with our bind. And we see those things align quite well. And so therefore, this should align similarly here. Indeed, it really seems like it does. So we have the right type, but then the implementation, that's where we need to use this, and in this case, actually pass the f as a second argument. Ooh, yes. And then we can run bind prim identity f, and we type check. Yes, yes, yes. And then let's continue. So plus values are actually not so hard to do. It's just here that we'll need to say that this is bind MAF in the way that this is just bind MAF. And then this is just bind MAF again. And same here. And that's consistent with the regularity we see here, so that's nice. And then here, similar thing. We'll do bind of, in this case, first plus MA plus MB, MC, and F. And that's it. And then here plus, but then we'll bind MA and then F. And then plus will also then bind MB with F, and then we're done. Almost. We are done here. Yes. And so we're left with this complexity here, where we're going to need to do another little trick like that. So here we're going to say that this is E prime. And okay, let's start simplifying this in the same way as the rest. MA on one side, and then on the other, a function that goes from A, but we don't have A handy right now, but it would then bind FA to G, and we also don't have a G handy quite yet. But we can maybe get those things by applying E prime to a function that would serve that purpose. And where go prime will be able to pattern match an MA and an F, which will make this code work. And we have a extra parents here and extra parents here. and a missing parents here, and plus, plus should take 2 things, and now we don't have a node instance here for some reason. Ord instance we should have when we do S identity, shouldn't we? Like this, right? Like S. F needs to be something that carries the Ord instance. So who wants an Ord instance here is one question. S union wants one, I think. Yes. And S identity should provide us one, but maybe run MA might not. Is that the thing? But the fact that these are both in prim should mean that we don't care, because prim is going to give us the Ord instance. But maybe we need to define a prim union that will, well, will it take 2 S sets? So will it take, yeah, maybe. And it would just union them, but it would have the Ord instance available. And it would do what? Prim blah S union S1 S2. Then we do prim union here of this and run MA. Apparently not. Buying a function. So you think S identity doesn't have an Ord instance here? I am doing it in the right direction, right? It's not identity S, no. A show. So not that then. Okay. Well, I suppose I've made some progress here, so that's nice. So I feel a little bit like I should post it in the gist. and get some help from the higher ups. So let's just do that. Set monad, work in progress. Main.purse. And boom. And boom. We're gonna have access to all of these things. I don't know, but we don't need cores anymore. We actually don't need the nested tuples anymore either. Nope. And non-empty we don't need, and data sets we do need. And yeah, maybe we need to call this main. And then we can create our gist. Boom. And boom. Or not. And that is the error. Log, awesome. So, okay, I think I made a bit of progress. Starting to get a little bit more confidence is a big word here. A bit more like I know what I'm doing. Nah, that's not even true. I get a little bit more familiar with the territory. I think that's more accurate here. And I'm starting to get a little bit more familiar with the territory here. However, I'm stuck, and strangely at the same place I was. It is, isn't it? Blah blah blah. Just, oh damn, I restarted. I hope it saved my yeah, it did. Okay. Yeah, curiously I think this is exactly the same place. It could not match constraint type, and I'm getting something very similar. No type class instance for org. Okay, it's not exactly the same thing. It's pretty close though. It's pretty close. Same place I was at the beginning of the thread, and it's not exactly the same place. At the same place this time with well, okay, same place I was at the beginning of the thread, though this time with a no instance found. Error. let me know if at least I'm heading in the right direction. And thanks a lot for the support. Okay, I think that's going to be it for us. Thanks so much for watching. A little bit more, probably another session on this rabbit hole. I mean, we have the whole library to to implement after we solve the workhorse there, but this should be much more easy, I think, because this is really where the smarts are happening. So let's see where that takes us. Thanks a lot for watching, and we'll be back on Saturday with more of the same. Bye bye.